Define that before we proceed further. We said GIS is a tool for collecting, storing, retrieving, and at will transforming and displaying spatial data. Yeah, Lord defines spatial data.
Are we going to get soft copy of it?
Yes, sir.
No?
Yes, sir. So, well, because we are getting soft copy doesn't mean we should not jump. Alright, and we are going to try as much as we to give you. Is either the soft copy or the hard copy? Get one of that.
Get the soft.
You want the soft copy?
Yes.
Okay, no problem, sir. So now, for this, we talked about what is GIS. We said GIS is what collecting, storing, retrieving, and transforming what spatial data. And we said spatial data is spatial data. Yes, spatial data. Sorry, spatial data is information that carries location, attribute details that takes location. Or let me say information like buildings, addresses of a place, coordinates. So far those information can be located somewhere on this earth surface. They are what? Spatial data. So at the end of it all, you do what? You transform and display this spatial data in a form of map. That's what we're talking about. So it's not just about transforming or displaying your data as a map, but also doing what we call let me get from this other place. We do what we call manipulating and analyzing. Yes. So when you are manipulating and analyzing your data, you are getting informations. You are getting better decisions to what you want to do regarding that GIS map. Alright, so that is all about GIS. Does anybody want to ask any question before we proceed? Like I was saying before, we talked about the 5 components of GIS. They are very, very essential. One of them is the soft hardware. The hardware comprises of every instrument, equipment that we use in carrying out any GIS project. Be it a printer is an hardware. Like a mouse here is an hardware, so far is what we are using. The computer itself is an hardware. You understand? So an instrument also like drones, we've heard of drones these days now, they are very common. Drones are hardware also. Satellites is an hardware. So any hardware, any physical instrument that we can touch that is used to carry out this project, any GIS activity, is called hardware, part of the components of GIS. So now we have the software. So software involves the functions, the tools, the manipulation, those things that makes it easy for us to be able to carry out GIS tasks successfully. So these functions, this software, example of it is the ArcGIS we are going to be using in this training. Another one of it is the QGIS also. Can anybody tell me any software we can use in GIS? We must have heard of software. Global Mapper, yes. Anyone else again? Anyone can tell us. I know all of us know this thing. All right. So we have AutoCAD, we have Google Earth, and we have Google Earth Engine. We have a lot of them like that. And also we have remote sensing software like that. Like software, we have the one for this trying to can remember the one for Snap, and also we have I think we also use this software 2000 and software 8. And also we also use architects too. All these architects, all this information, so far they carry out locations, so far they can execute functions of GIS. They're also part of softwares of GIS. So what is the data that we are requiring for this component of GIS? These are spatial related data that carry out location attributes. So these data are geographic data. Geographic data simply means information that we see in our surroundings, phenomena that we see in our surroundings. So an example of this location data, geographic data, can be NEPA poles, can be this building, can be your car. So far it is located somewhere on the earth. Can be a building, a residence. For those that are into public health, it can be location of hospitals, location of schools, location of residents. For those that are into engineering, sorry. For those that are into engineering, you can talk about data for all these pillars setting out of layering, leveling, spot height. Those are information that you get on the road. Sometimes you want to do road lineament, all those things. And some information that are based on agriculture, for those that are into agriculture, you take information like your types of crops. So far those crops are on the earth surface, they have a location, their attributes, their geographic data. So all these geographic data, you play around with them. You try to get results from them for your own better suggestions, for your own better decisions. So now, all these geographic data I've mentioned, can anybody also help me with any other information that we use that are related to geographic data? Can anybody help me with any of them? Rivers, land, yes. Trees, yes. So if I'm moving too fast, please draw my attention if you are not getting along with us, please. I want every one of us to move on the same page. I'm trying as much as possible to make it so basic so that all of us can understand what we are into. So these geographic data are the informations we need. These are informations we need to carry out GIS projects, to do any analysis. Without geographic data, it's just nothing to us. So geographic data can also be, okay, it can even be on electricity. They call this one spot eye, they call them elevation informations. It can be the elevation information of a road of a particular location. It can so far it's even a name of a location. If I give you the address of this building now, the address of this building, that is the geographic data. With that geographic data, you can format it to geocode it to coordinates and do a lot of things with it. So all this information, so far they are located on this earth surface, so far they are within our surroundings, so far they are something we can see. Even some of those things we can't see, so far they are located like temperature, like weather. Those are also geographic data. So we use this geographic data to make decisions and better suggestions for anything we want to do. Imagine you want to you want to build a house now, you want to build an estate. You need information to help you with the foundation of that estate. This geographic data. Imagine you want to build a road now, you need information like geographic data to help you with how many sound filling you are going to do to get true leveling of that area.
If it is lines or polylines, we'll talk about what features can we represent using polyline or line in GIS environment. It can be road, it can be river network, depending on the scale at which we are mapping. If it is Jabi River and the scale is kind of a large scale, which means we can have it in polygon. If it is a small scale, it can be in just lines. Well, okay, we can have road network, we can have rail network, we can have pipeline. What other linear features can we have? So it is like that, inexhaustible. Then points, it may be well water, it may be borehole. So these are just like point features you can use. It may be electric pole, EP, and like that. While in raster environment, this raster environment, it can be very crazy sometimes to work with. That is more like GIS, remote sensing analysis, moving away from vector. Remote sensing analysis, where we talk about acquiring satellite imagery, trying to do some rigorous processing. Because in Abuja now, let's say we want to look back like 30 years ago. What is the level of development in Abuja? So we'll say we'll pick a particular year, 30 years ago, maybe in 1980 or 1990, we can get a satellite imagery for a particular year, a particular month. Then we'll make sure that there are so many things we can check so that our results will come out very okay. Something like cloud cover and some other stuff like that. But when selecting which satellite imagery to use, there are some criteria, there are some things as a spatial analyst that you have to bear in mind before you do any download. So we acquire an imagery of 1990 and want to give it like 10 years interval, or like 20 years, or 15 years, depending on what you want. So we get satellite imagery, maybe Landsat imagery, of 1990 covering Abuja. Then we move again, let's say 10 years or 15 years or 20 years. For 2000, we acquire another imagery. Then 2010, another imagery. Then 2020, another imagery. We can get it like that, independent of each other. Then we carry out image classification. That is a pixel-based environment. Because when we talk about raster, that's when we talk about pixels. Because when we take pictures, the more you zoom your picture, you discover that you're seeing some lines that are like, they look like cube of sugar. Those are pixels. You represent raster images using pixels. So those pixels are what satellite has used to map the Earth surface. And when you download as spatial analyst, you can use your knowledge to carry out image classification, such that when you get it into a GIS environment, or even using proper software which are like remote sensing software like MV, like Snap. Snap can do image classification as well. Then Iris can do it as well, and some other related software like that. When you carry out this image analysis, you can get the built-up area for 1990. You can get the vegetation for 1990. Those are the different classes. Those are the results that we should look forward to. As time goes on, I will show you some of the results of the remote sensing analysis that we have done. Vegetation, water body, built-up area, which is like urban, and some other image classes that may be in our results. So when we have it for 1990, when we have the results for 1990, we can have for 2000, we can have for 2010, we can have for 2020. We are trying to determine urban growth between 1990 of FCT Abuja, between 1990 to 2020. From here, we carry out our statistical analysis. We can know the area in kilometers square of each of the classes of lands that we have done, that various land use classes. Let's say urban, then vegetation, then wetland, then built up. All these, we can have the statistical analysis for it. Then we'll have the area for this. We can have for this, we can have for this, and for this. From here, we'll be able to make comparison. You will see that by now, due to developmental activities, you will know that you see that urban is gaining more weight. It will keep increasing just the way the development has been happening since 1990 till now. Then water body too, you can analyze. Maybe, probably in some year, maybe there was drought, there was high intensity of flooding, or probably sun. It will either shrink, or you can have much more water body like that. And when you do this analysis, you'll be able to make comparison and determine the urban growth and even the direction of the urban sprawl.
Can I say something?
Yes.
I think it might be helpful to take a look at vector and raster in terms of a vector, by virtue of its definition, is a series of points, and each point has an x, y, and z coordinate. So vectors are basically, feed-off coordinates. Each of, a line is 2 points, a polygon is 4 or 20 points, as the case may be. So it's feeding off figures, x, y, and z coordinates. But a raster is overlaying the changes in images. But even at that, you would have had to define what is a building, what is a water body, so that when the system is, doing that interrogation, it knows where the changes are based on the images. So you could say the raster is a non-mathematical, but the vector is a mathematical. I think that's an easier way to look at it.
So then the scaling and coordinate source with our data sets, we can get assign a coordinate system for our data sets depending on the device that we use to acquire the data. When we use a handheld GPS, we set it maybe to WGS84, to million datum, and all like that. When you are doing that, you are always very conscious while on site, so that when you get to AppMap environment, right from when you are bringing in your data, you'll be able to define the appropriate coordinate system or data source for what you're about to work with. So I'll let you continue.
All right, thank you very much. So I believe we are following up with what we are doing. I want us to feel free to ask any questions, because at the end of the lecture we'll be doing a test like an analyzer before you get the certificates. And as if you don't understand this, it will be difficult for you to be able to relate it when we are doing the practical. You get? So there are some basic things that I believe some of us have done something like this way back, but I want to make sure that every one of us has functions of GIS. We've talked about what capturing is all about. That's part of the functions of GIS. We talk about capturing data. So we said capturing data, these are one of the ways you can capture data. You can use a drone, you can use a digital, you can use GPS, you can use satellites, and you can use it in form of coordinates. So far you have these coordinates, you can locate them on any way of the Earth's surface. So far you have a drone, you can get an image of a place and geotarget. So far you have a satellite image, the satellite image will come in the form of geographical reference information, whereby you also geocode georeference, sorry. So all these grammars that are looking to be, we'll be doing them in the practical sections. GIS is one of the easiest software to write. Does anybody believe that? Alright, girl. So he mentioned the storage of GIS. That's the vector and the raster. So the vector data comes in form of parties, right? You have one point to one point that joins another point to make up a line. The closed vector is in form of a polygon. So your vector data can either be a point, line, area, that's a polygon. Alright? And the raster data, like I said, are in form of pixels, in form of a picture. So when you zoom this picture further, you'll be seeing some box like in different colors that sums up this picture. Alright, that's when you start seeing infinite, that we'll be saying they have 47 megapixel. An iPhone that is still the latest is having like 12 or 15. Alright, so those pixels, the more the pixel, let me be like, the more clear the image is, and the more data you can get from the image. Alright, so we talk about query. That's all about questioning. So this is in the form of a query expression. So you query whatever you have in the database, whatever you have in the software to display on the map. So far you are looking for somewhere like you're looking for Wuse Junction on your map. You can query it and it will show you the location. So another better explanation of query is just like Google Map. When you are trying to search on Google Map, work and connect, you just type it there. It's a better explanation. You are questioning Google Map database. Where is Wuse? Where is Jabi? Where is Abelishama? So
I had a bad experience using it this morning.
I serious.
Honestly, I had to go around somewhere I already know.
That is a limitation of GIS. Then you cannot come now that you have seen a loophole. You want to bridge the gap.
So that thing that you suggested is the disadvantage to this place now. You found it difficult to locate this place, despite the fact you use Google Map. That means the location here is a bit poor. You understand? Do we understand that? So if you're having a location of a business, there's what we call it's kind of site foresight. I've forgotten the name of that. Something foresight or something like that. That a customer at every junction should be able to cite your business, your banner. Something like if you are doing all this banner about physical adverts, there's what we call some analysis in GIS that we use it for marketing. Your client is supposed to be able to cite that building at a particular angle. So when we go into Esri City Engine, has anybody used Esri City Engine before? Alright. So let me not go further into that. Query is all about questioning the database, giving you information that has already been existed in the database.
Excuse me. Just on the example he gave,
Yes.
if you think of Uber or
Yes.
Bolt, your address gets stronger the more people use it.
Use it, yes.
So the likelihood is this might be weak because not too many people have used it. So it hasn't been triangulated by a lot of databases. But by the time more people get to use it, that problem may no longer exist. That's what Uber and Bolt are built.
Yes, him is actually talking about locating the building. I think you passed in front at the back of the building, right?
I had to take the other way.
The other way
around
side.
through and then.
The building was looking close to the road, but there was no formal entrance from the road directly to this side. So the entrance for this building now is in front. So probably what was suggesting is people have been passing there every time. You go and put the road.
Alright, in a way, this training now is like a blessing to this building. Because we have people that have used Google Map to locate this place, just this one.
Yes. And there's actually an entrance, but it's a small place. Yes, just for that plaza. Yes. So, does anybody have any question before we proceed? Okay, please feel free to ask questions. So now we talk about analysis. This is just among some of the analysis related areas. So we talk about proximity analysis. So proximity analysis, you're trying to, how many house lies within 100 meters? Something you're talking about distance between a particular object or maybe a phenomenon to wherever you want to calculate it to be. Customers, location of customers around that area, location of hospitals around that area. These are proximity analysis. So if you are doing analysis, if you are doing a project, if you are asking yourself, am I going to do proximity? Am I going to do query analysis? So in proximity, you can also make use of query analysis. Yes, query analysis is more about combining the feature of two layers to create a new layer that contains the attributes of both. So most time it will be better understood when we are doing all these things as we proceed. Don't worry, when we go into the practical section, starting from next week Saturday, everything we'll be doing is practical. We'll be hearing something like UFA, that's the proximity analysis. Sometimes you hear some grammars like that. All those things are proximity analysis. You'll be hearing query analysis, you'll be hearing network analysis. Overlay analysis. So overlay analysis is more of getting information based on two data overlaid on each other. So like he made mention of this 1990, 2000, 2010, 2020. We did something that is an animation for Lagos State Vegetation. We were trying to get the information that was done in the past compared to what we have in 2000, compared to information we have in 2010, compared to information we have in 2020, like built up. We want to see how it is expanding. And one truth is that if you are the type that buys land, you will know where it's developing more and invest in that area. Really some people, if you are the type that invests in land, you can just sit down, you can tell maybe one IT student, give me the map from 1990, from my father's time, give me the map from, and you want to get the information of how buildings are progressing, how residents are progressing, how the urban is expanding. Then you can know that, okay, this land that people are not really looking at, people will still buy it in near future. Then you can now start to predict. So when you overlay this information together, you now want to do something like vulnerability analysis. You want to get which place is more vulnerable to people's interest in land. When you now overlay all these four data together, it will give you your results of where to invest in. That's what we call vulnerability of sensitivity analysis. So as we proceed further, analysis is the very, very interesting part, and that's why I say that it boils down to how you can think, how far you can reason to your data, how far you can make information, how far you can make better decisions based on the old manipulation, based on the old analysis of your data.
So on proximity analysis, there are a few key things that we're going to be doing. Because I made mention of there's a teacher there, and we talked about site selection in the location of schools or public facilities, and what you need to consider. We're probably close to villages so that people can have more access to education. So on proximity analysis, then we talk about buffering, buffering. We're going to be doing practical on that, such that you have a particular input, maybe a school. When you input it into the GIS environment, then you can run your buffering analysis and it will form a ring around that school. All the villages that are, let's say, like 500 meters or 1 kilometers away from that school to form a ring. Not like forming kind of radius around that particular school. You can make decisions with it and many more. Then there's an analysis called nearest neighborhood analysis. It looks very close to buffering as well. Nearest neighborhood. When you run the analysis, it tries to determine who and what is my neighbor, and it gives you results. Then you can further analyze it and write reports on it in order for us to make people understand the results that we've gotten. Then overlay analysis, simply trying to get data of the same position, especially reference data. Maybe I'm acquiring data for this very in form of polygon. We have it in form of polygon, but there are boreholes that are around. You can pick it in form of points. There are road networks, just little road networks connecting this building, and we can have it as well. Then when we overlay, we can do display, then we overlay them so that we can have a form of holistic view. We have the boreholes that are existing in this particular area. There's one job I recently did in Asoko. We went to do ground survey, basically ground survey. We mapped out the very building. After mapping it out using a data station, you go to collect the eastern and data. Then there are boreholes, 4 in the building. The map just as points. Then the road that is connecting the building, we're able to map it as well. We're able to display it, then do some embellishment in order to get the result that we need. That is overlay analysis in vector environment. When we talk about overlay analysis in raster environment, depending on the analysis you want to do, maybe flood vulnerability analysis. I'm a flood expert. That's where I joined. I did my MSc project on that. So I know a bit of flood mapping well. So what I did was I used multi-criteria analysis in order to determine the levels, some areas that are highly vulnerable to flooding. By multi-criteria analysis means what are the factors, or what are the criteria, what are the factors basically that you can assemble that can influence flooding in a particular area, and how do you give it weight? Then when you do that, how do you integrate it, overlay it, and rigorously process it, then get a single result, which is the flood vulnerability map, or flood hazard map, or flood risk map. So talking about the factors that may be responsible, in an area we know that flooding is always occurring due to one, torrential rainfall. So when we talk about rainfall, we know it could contribute to flooding. It's a flood contributory factor. We pick it as one, rainfall. What other thing can we think about? Is it the elevation? Like, is it because this place is kind of depressed? That's why water will always flow from point A easily to point B and get the place eroded. So we can talk about slope. Yeah, elevation, which is the topography. Then from there, how do we get all those? People will be like, I cannot carry out the analysis. It's going to chop my money. No, calm down, be calming down. This is remote sensing, this is GIS. It is not everything that you have to pay money for. Sometimes it needs you to just sit on your own, do some research, find, so people that are in America, that are outside this country, that they've done a lot of work for us, and there are some data that are freely available online that we can download with just our data. Then we can do some rigorous processing, then integrate, overlay, and get results. So talking about slope, talking about elevation, talking about aspects, talking about NDVI, talking about land distance cover. So these are the factors that I'm already mentioning, the factors that I used. Slope from digital elevation model, you could carry out slope analysis, get your results. You could carry out elevation analysis, get your results. So you are seeing all those factors the land use land cover from Landsat imagery, you could carry it out. The reason I consider land use land cover is because there are some anthropogenic activities, human activities, that contribute to flooding, probably due to indiscriminate exactly. So it is a factor that is worth considering. Then we talk about vegetation as well. Where there are grasses, it may be a little difficult for water to move freely. Then we talk about NDVI. That's NDVI. NDVI. Is it something natural difference vegetation index? This N, I can't really remember. So it's NDVI. Carry out that NDVI analysis as well in order to map the areas that are better, that are more exposed, and the areas that have vegetation. We know definitely water might find it very difficult. So when you have assembled those factors, then you talk about geology. We need geological map. Then you talk about soil map. So when we talk about drainage density as well, when you determine the level of the drainage and how water flows, how water accumulates and how it flows. So when we combine all those factors, we can integrate them, do some overlay analysis, and get a single result, which is a flood vulnerability map. That is just like a brief idea of what overlay analysis could be, both in vector and raster environment. The network analysis as well. This very analysis can be kind of tedious sometimes to work with, but it is in a way in vector environment. It could be as simple as it can be. Network analysis. What are the road networks that can lead me to my particular destination on time? That is what Google uses as well. When you are moving on a particular route and you have queried a particular spot, it will give you, if you do some network analysis, determine your position, determine the position of where you are going, and find you the fastest route or the shortest route. And it will even show you areas that there is traffic gridlock. It will show you the better way in order to lead you to your destination. That is a bit of network analysis. So all these things, away from the English and all, when we start doing some little clicking, maybe we really appreciate what it all is.
Alright.
Can I do for the rain, I mean, for mapping in the rain or canal also?
Rainfall.
No, drain.
Drainage.
Okay, yes. Yes.
Or a canal.
Yes, you can. It depends on the way you want it to be. Like now you said your reason for mapping is for drainage. Now your idea is which data will you use to get your drainage? So now to get a drainage information, you can be using something like digital elevation model, where you can get spot height. The more spot heights you get, the more accuracy of digital